Yes, so yeah, if you have any questions, you can ask on Moodle or on eLearn. Uh, I think if you ask on Moodle, it's better because the question will be posted. We will also get an email that you have posted a question, and other students will also be able to see, and that is useful. Just give me 1 minute. So in order to do homework, the problem 8 in homework, you need to know one small idea which I will discuss in today's session.
Belated happy birthday.
And there is a part 2 to lab 2, which is primarily on different ways of using printf and scanf. So that also I will release today, and you will work on that problem set also a couple of days. Yes, Harsha, I told the office to enroll spec students to the model.
Exam.
Couple of things actually, there is a, so we have a course textbook, and for some reason it is getting delayed. There is some delay in procuring the course textbook. So because of that, some of you are having no trouble. So what is the reading assignment? So actually after today's class, the reading assignment essentially for you is chapters 1, 2, 3 of the book. All the ideas discussed so far in this course, they are from chapters 1, 2, 3 of the textbook. And the slides also I will post. So you will have all the references available by the end of today. So you can use the slides for reference, and you should read the textbook, which is better. The textbook is really good. I strongly recommend that all of you read the textbook carefully. Chapters 1, 2, 3. Till chapters 1, 2, 3. Chapter 1 is kind of a more intro kind of thing, but overview kind of thing. Chapter 2 and 3 are where the details are there. So you should read chapter 2 and chapter 3 of the textbook. So reading assignment means you don't report anything. I'm just saying, hey, this is the content that is being covered in the class, and you can reinforce those ideas by reading these chapters in the book. You don't need to report anything back. Is there someone who is not I couldn't hear the noise, so that's the reason I'm not So the book will be available. Hopefully it's an ebook you will get. I hope you will get it by today or tomorrow. So there is a copy of the book, but no, it's not good to use. The official licensed ebook, you will get it hopefully by today or tomorrow. Just want to do a speaker check. Can someone say hello? And
hello, sir. Sir, can you hear me?
So because I am not sure if I'm able to hear.
Hello.
Hello, sir.
Prayam is talking, I guess, but I'm not able to hear. So then that means there is some settings problem on my side.
Sir, can you hear me?
Hello.
So now can you speak, Frame?
Hello, sir. Can you
Okay.
hear me?
Thank you, Frame.
Yeah, okay.
Supple.
Thank you.
Good. Awesome. So as I told, uh, the first part of the course is on the basics, essential basics. And if you see in lab 2, what you will learn is how to write straight line sequence of code. So in the class on Friday or maybe on Monday, you will be introduced to what are called as if statements, where based on some condition, you execute some piece of code versus some other piece of code. But so far we are looking at code which is just a straight line piece of code, that is, which has straight line piece of control. That is, the control starts at the beginning of the program and the control ends at the end of the program. All the 8 problems that you have seen in lab 2, they have this property that they have the control is a straight line sequence of control. So if you know more and if you use loops, etc., in solving 1 or 2 of these problems, it is all right, no problem. Not an issue if you use loops or some advanced constructs, if you use, no problem. But those of you who are not aware of them and who have just written straight line sequence of code or code where the control goes only in straight line, perfectly fine, not a problem. Okay, let's get started then. We will we will look at printf and scanf in bit detail in today's class. Let me share the screen. Great. So I want to, so let's look at this code, this printf code that is there on the screen. So this is a very simple code. There is one variable I that is declared, and that variable I is declared as an integer that it holds values which are of type integer. And on line 7, it is initialized to 100. And on line 8, we have a printf statement which prints the contents of the string, which prints whatever the format that is, uh, which prints as per the format string that is given. So let's compile this code and see what happens. So this is gcc printf 0.c. And since I am not using -o option, so the executable is generated in a.out, and I am executing that file, that program /a.out. So I is equal to 100. That's how it get printed. I want to recap the ideas discussed in the last class about this how this whole thing works. It's if you understand this, see, there are 2 ways. At one level, yeah, this is what it is, and you can use this in your program, but you can have a deeper level understanding of what is happening when this printf function is being called. So if you see between these double quotes, this is what is called as a string literal, and this string literal, this whole string will be stored in the memory. So I equal to, so actually there is a space also there. So this is space, okay, and then equal to is there. So this in memory, your string is stored as a sequence of bytes. And every string, it ends with what is called as a null character, which is written as \0. I wrote it very badly. Let me \0. This is called as a null character. And if this array, this sequence of bytes, it will have a base address. Let's say the base address is 100. And this is your RAM. This is your main memory. And somewhere in the main memory for your variable I is also allocated. And let's say I is present at address 150. This is the address of I. Address of I is 150. And the value 100 is, by the time the control reaches statement 8, 100, the memory location associated with variable I contains 100. So for the printf function, when the printf is a library function, when the printf function is called, so printf will be passed two parameters. One parameter, this is printf function, and printf is passed two parameters. One is the base address of the string, which is 100, and other is the value associated with the variable I. That is the contents of variable I. In this particular case, it so turns out this is also equal to 100. All right. So in order to kind of make it less confusing, make it clear, let's say the base address of this array is 50. So 50 is passed. 50 is the base address of this string, and I is the value, the other parameter that we pass is the value that is associated with the printf. What the printf does is it looks at the it looks at the base address of the array, and so it looks at I, it prints I onto the screen. It looks at space, it prints space. It keeps going like that until it hits this special character %, which is a format specifier. So when it looks at %, it looks at the next character, and if the next character is D, then that means what it does is it goes and looks into the the second parameter that is being passed, which is I, and in this particular case 100, and it prints 100 in the place of %D. So after %D is processed, it goes to the next character, which is new line. So it prints a new line character onto the screen. And after the new line character is printed, it goes to the next character, which is null. And the printf function knows that the entire format string is finished. It has come to an end, and that's where it concludes. So this is how printf function works. And the second thing is printf is a function. It returns some value also. What it returns is the number of characters that it successfully printed on the screen. Like for example, we want to know, like for example, I am using one more, let's use one more variable, int return value. So printf, let's see, I have whatever the value which printf is returning, we will store in this variable return value, and then we will say printf number of characters printed by the previous printf %d /n return underscore value. So this is our whole program. So we are printing the number of characters printed by the previous printf statement. So let's compile this program and see what happens. /a.out, and it says the number of characters printed is 8. So if you can count, I is one character, space is another character, equal to is another character, and this is the next space is another character. So there are 4 characters till we hit the first one. And once we hit the first one, so it prints 100, 3 characters. So we have 7 characters. And where is the 8th character coming from? The new line is the 8th character that is coming from. And if you, let's say if I is equal to 1000, then the number of characters printed should increase by 1. And let's see if it happens or not. So now you can see that the number of characters printed by printf is 9. So this is how the basic printf statement works. And before we move further, there is one idea that I would like you to understand. Let's see. Printf 0.
Sir, I have a doubt, sir.
Yeah, I hear a question.
Yes, sir, I have a doubt, sir.
Yeah.
Can you go back to that code, sir, once?
Yes.
Here we are assigning value. We are defining a return value as a variable, and we are assigning the value of printf to it, no, sir.
Yeah, the value returned by printf to that variable. Yeah.
But why is whatever is there in the printf also getting printed? We are just assigning the value.
No, not printf does 2 things. One thing it does is it prints whatever that format as per the format specifier onto the screen. The second thing it does is it returns the number of characters it has printed on the screen as a return value to whoever is calling that function.
So we can put any function as we can assign some function to a variable, and still that function will go on also.
No, it after printf executes the value, yes. Printf returns a value.
Yes, sir. I'm saying, why does printf even execute here? Because it is we are using it to define only, no, sir. Why is it getting executed here?
We are using it to define. No, we are calling printf to execute. No,
sir. What I'm saying is printf is returning a value, and we are saying that.
No. What is printf does? Printf does 2 things. Just hold on. Yes. Printf does 2 things. First thing it does is it prints whatever you have asked it to print. Number 1. Number 2, after it is done with all of that, let's take a look at the code of, let's say this is int printf with some format. So printf here, it prints whatever you asked it to print. So finally it returns some value. Whatever the value that it returns, it is the number of characters it has printed on the screen.
Yes, sir.
Okay. So here in the first part it does the actual print, and finally this is the actual print, and after printing it on the screen, it does one more thing. It returns the number of characters it has printed on the screen.
Yes, sir. My doubt is in line number 9, sir. Okay. We are assigning return value is equal to printf something, no, sir.
Okay.
So that I is equal to %d with the value is also getting printed. So does it always happen that can we even when we are assigning value to some variable using a function on the right hand side, like using a statement on the right hand side, will that statement also execute itself? Like here,
of course it is executed. So please try to understand, when you call printf is executed.
Okay, sir.
Printf is executed. You are calling printf, right? So printf is executed. So when printf executes, it does 2 things. One is it prints something on the screen, and after it prints something on the screen, it returns the value. Then what is the value it returns? The number of characters it printed on the screen. And that value, so this is the way you should think. Remember, this is the box that we have drawn. So this is our printf. And so here you are passing parameters to printf. So printf does some printing here, and it also returns a value. So printf here, so as a side, so it returns, there are two things printf does. One thing is it prints something onto the screen. So let's say this is your screen. So on this screen, it prints something. And after it does the printing, it returns some value. What is it? What it returns is the number of characters it is printing on the screen.
Excuse me, sir.
Yeah.
Thank you,
Sir,
sir.
the integer we were printing, it was in integer format, 1000. But when we are returning the value, it is showing it as 4 characters. So is it converting that integer also into character format and then showing 4? Because,
What do you mean?
sir, because I was integer, right?
Okay.
And then when we printed it, it was showing it as 4 characters.
Yeah, that's true. That's true. It is converts into, it treats 1000 as 4 characters. That's true. Yeah.
So not as integer.
Not as integer. It translates that integer into a sequence of characters so that it can print on the screen.
Okay.
Sir, I had a question.
Yes.
Sir, you said yesterday that every string is terminated by a null character, but sir, that probably wasn't counted here. So a null character doesn't
Not
qualify as
counted.
a,
Yeah, null character is not counted.
but
Because
it
null
does.
character is not printed on the screen. Nah?
All right, all right. So, but it does hold a space in the memory, right?
It does hold space in the memory, but it's not printed on the screen. It just serves the purpose of that the string has ended. That is its purpose.
All right. Thank you, sir.
/n is one character. New line is one character.
So that means it counted the null character, right?
No, where is it counted?
So because if you count this, it comes up to 7 without the null character.
No, the last one is the new line character. It's not the null character. Because
No,
we are going to the
including the new line character as one character, it comes up to 7.
No. Okay, let's see. So now let's do this simple exercise in order to make this counting easy. So,
okay, no, sir, I was wrong. It takes 100. It takes 100. Yeah, got it, sir.
Sir,
I have a doubt.
Yeah.
So the space is also counted, right?
Yeah, space is also counted. Space is a valid character.
Okay.
Sir, I have a doubt.
Yes.
When we normally use printf, it should return a value, but wouldn't that create an error?
Why it would create an error?
Because there would be a return value that was not used. Like it will be free
It's okay.
in the
That's
main
not an
function.
issue. If a return value, if you can afford to discard a return value, it's not a problem. You don't get a problem with it.
Okay, sir.
Sir, am I audible?
Yes.
So say if we want to take the number of characters and we are not interested in the printing part, so we want only the return value of the printf statement. Is it possible to just obtain that and not execute the body of the function?
I'm not sure. I don't think there are. If you, yeah, I don't think I'm not seeing a programming use case for what you are asking for. You want printf, but you don't want what you want to print on the screen. So I'm not seeing a programming use case for this.
No, I just want to calculate the number of characters and not not print the actual output.
Okay. There is another way to do it. Maybe at some other point in time, we will revisit this question.
Sir, if you just don't want to see the output, can't you just clear screen after the printf?
Sorry?
If you just don't want to see the output on the screen, can't you just clear screen?
No, it's not like that. Before he prints, he wants to, we would like to see how many characters that will be there in the string that will be printed. So it's just not about clearing the screen. It's like maybe you want to plan the screen in some fashion based on the length of the string that is going to be printed.
Sir, when the string of characters is stored, like I space equal to then the percentage d, in the memory slot allocated to space, is it empty or are there any random characters
No, no,
present
no.
there?
In the memory that is allocated to them, the corresponding values will be present. No?
So for space, it would be just empty.
No, no, I will let you know what it is. For space, what it would be. So there is a representation, there is a 1 byte representation value for each of these characters. For space also, there is a value like maybe 3240 or something like that. And that value is called as an ASCII value. So we will get to that. Okay, good question though.
Okay, thank you, sir.
Yeah, let me write one more. Before we move on, I want to introduce one more idea which is necessary uh, for the homework, and which is, so let's say you have, so you have a program like this, printf, I is equal to %d slash n.
Sir, you forgot the quotations on one side.
Oh, okay, let me fix it. Yeah. So I don't need this return value variable. Okay. So here is a simple program. This is which. So here on line number 7, remember this is the memory. I want you to keep this memory model all the time. So this is your memory. And so variable, this is variable I is allocated this memory. And the address is 100. And you are holding the value 1000 here. And on line 8, we are printing the contents of the variable I. And on line 9, we have a statement I is equal to I plus 1. So many times when you see programming for the first time, this is confusing because this is not a mathematical statement. I is equal to I plus 1. It's not a mathematical statement. It's a programming statement. What it says is the I here, it tells when I is used on the right hand side, whatever the value that is present in the memory at that time will be used. So here when on line number 9, when I is used on the right hand side, okay, so it is used on the RHS. So let me not use RHS because it reminds you of your math. So I think the right word is R value, I think maybe. So the value of I is 1000. So 1000 plus 1 is 1001. And after statement, and then this 1001 will be assigned to the memory location associated with the variable I. So after line 9 gets executed, what happens is the value that is present in the memory location associated with variable I is 1001. So this is an important idea, and you may want to use this idea in your problem 8 and in few problems in lab 2, 1 or 2 problems in lab 2, you will be using a statement where the same variable occurs on the left hand side and on the right hand side of an assignment statement. If a variable occurs on the right hand side of an assignment statement, we use its value, and if the variable occurs on the left hand side as an assignment statement, we go to the corresponding memory location associated with that variable and update that memory location. So let's execute this program. So gcc increment.c, and you can see, so I is equal to 1000, and after increment I is equal to 1001. And of course you can use any operator here. So you can use, like, for example, -1, and you can say after decrement, and you can see, so after decrement I is equal to 990. So this is an important idea that you may want to, many times you want to use the same variable. So there is a variable and you want to keep working with that variable. You may want to increment the variable, decrement the variable, or add two variables and store it in a third variable. All these things you can do. And this particular idea that if a variable is used in an expression, so I-1 is an expression. If a variable is used in an expression, then it's the value that is present in the variable will be used to evaluate the expression. And when it is used on the left-hand side of an assignment statement, then in that case, what we do is whatever that is the value that is evaluated on the right-hand side, we go to the corresponding variable's memory location and we update that memory location. Are you all with me here on this particular idea? Great. So I will show you one more thing also before we move. So take the same program. So the value of I is this, and so I want you to understand. So there is a %p memory address of I is. So remember, when we apply this ampersand operator, what happens is the value that we get is the address associated with that variable. So now if you run this program, let's run this program and see what happens. Sorry. avdr.c. So you can see that the value of the variable I is 1000, and the memory address associated with I here is printed in a hexadecimal format, which we will see maybe few classes later. We will study hexadecimal format also. So %p usually we would like to use when we are printing addresses. That's the best way to think about it. And let's say, if you can repeat these two statements, Control C. So I is equal to I plus I. Let's say you want to do this, and then let me after
Sir, I have a doubt.
yes.
Sir, the memory address of I, is it I, the thing like when you wrote 50 is the address of I, or is it the address of the value 1000?
Sorry, what is it?
Sir, is this the memory address of I is equal to %p? So is it displaying the value of 1000 or where I was stored?
No. So 1000 is stored in the memory that is allocated to variable I.
So what is it displaying when you say %p?
That is the address at which the I is the variable is allocated memory.
So 1000.
No, the 1000 is not the address at which the variable is
I
allocated.
mean the address of 1000, right?
Not the address. That's not the right way to think, because 1000 doesn't have an identity of itself. If you see, this is variable I, So variable I has some address. Okay, this is variable I has some address. Now 1000 is present here, and if you overwrite it, like for example, after statement 12, 1000 will be overwritten with 2000. But the address remains the same. So 1000 doesn't have any address. 1000 is present in the memory that is allocated to variable I.
Okay, sir.
So let's execute this program and see what happens. So the reason we are looking at this code is the address that is associated with the variable I, or the memory that is allocated to variable I, it can keep changing, but the memory address remains the same. For variable I, so throughout the execution of the function main, the address that is allocated to, or the memory address that is allocated to variable I, it remains the same.
Sir, what happens when the printf command reads, like when we enter the printf command, what happens when the system reads the %p?
What happens?
When the %p character is read, what happens then?
What happens? It's very simple. So let me, before I answer your question, are you all with me on this program? So if you see this program, on line number 9 and 10, we are printing the value of the variable I and its address. And we are doing some operation using the variable I. And then on line 14 and 15, we are printing the variable I and its address. The
So just
idea is the contents of the variable I can keep changing, but the address of the variable I remains the same throughout the program.
Sir, why do we have to use the and symbol before I?
Sorry?
So why do we have to use the and symbol?
So that is what now I have been telling you multiple times, and I will repeat again. See, this and symbol, it tells the address at which the memory for variable I is allocated.
So won't we using it to assign it to that location, like when we were using the scanf?
No. See, you don't get confused, okay? So keep it simple. I means I refers to the content. So let's say this is variable I, its address is 100,000. When you want to extract the address associated with variable I, we use ampersand I. And if you just want to access the contents of I, you use I.
So
So
if
that's
I
what we
want
are
to
here.
access the address
Sorry?
of I, then if I want to access the address of I, then I'm using ampersand, and if I'm
That's true.
only
That's
the
true,
content,
exactly.
and for only the contents, I'm using only I.
Yeah, that's true. On line 9, we want to use the content. So we are using I. And on line 10, you want to get the address at which I is present. So you use ampersand I.
Sir,
Okay.
sir,
Thank you, sir.
Yes.
sir, hello.
Yeah. Please go
Okay,
ahead.
fine. So just want to confirm this. Like every time you declare an I, the program like stores the, I mean, picks a certain, like randomly allocates a random address for the variable.
Every time,
There's a random address for I, right? It's not like picked like the computer picks a random address to like store I in, right?
it's not exactly random, but it allocates, there is a methodology for allocating address for the variables, memory for the variables.
I
So
get
it's
that,
not
but
completely random.
yes, but like, so if I recompiled it, would it give a different address the second time?
Good question. Try it out. You will get a different address, but it will not
Sir,
be. Try it and see what happens.
Okay.
hello, sir.
Yeah.
Sir,
Yes.
if I store another variable in I, then will the location of I change?
What do you mean by storing another variable in I?
Like if I define another variable called J and store another value in it, and then I do I is equal to J, then?
Okay, let's see. So you want to J. So you can see. So here, let's see this. J I is equal to J. And let's say J is initialized to -1. So let's see what happens. Clear. So do you see, is the address of I changing? No, right? So what
Yeah, sir.
happens?
Okay.
What happens is on line number 12. So this is again very important when you are doing this the lab 2. So here what happens is whatever this is what is there on the right hand side, it is an expression. So you evaluate that expression. So in this particular case, the expression is a very simple expression with one variable j, and j contains -1, and that value will be assigned to the variable I. So what does assigning -1 to variable I means? So whatever that is the address, the memory associated with variable I, it will be updated. Like for example, here I is present and somewhere here j is present. Let's say, so initially I has 1000 in it and j has -1 in it. And after line 12, what happens is the statement that is present on the right hand side of equal to, that is j, it's not a statement, the expression that is present on the right hand side of equal to, it's a very simple expression j, and its value is -1, and that -1 will be copied to the memory location associated with variable I.
Sir, I had a question.
Yes.
Sir, if originally we assign a value to I that requires, say, 2 bytes or 3 bytes of memory, and then later assign a value that requires a much larger memory size, so much so that it overflows into a different address, does the computer reassign the variable like address of I?
No, the good question. The memory that is associated with I, it's a fixed amount of memory. So whatever the values, you have to only certain values are permitted, certain range of values are permitted. And if you try to assign a value which doesn't fall into that range, the memory will not be expanded, but things can go bad. But I will answer your question in more detail, maybe let's say 3 weeks later. It's a good question, but we will answer it, let's say 3 weeks later.
Sir,
Okay,
the
thanks, sir.
address here means address in the RAM, right?
Sorry?
Sir, the memory address here means memory address in the RAM, right?
Yes, the memory address in the RAM.
Sir, and if two variables are declared of the same type consecutively, it doesn't necessarily mean that their memory locations are also consecutive, right?
It depends. Yeah, so they could be consecutive, they may not be consecutive because compiler does lots of stuff under the hood, but they will be near to each other actually.
Okay, but it's not necessary that they'll be consecutive.
Yeah, it's not necessary they will be consecutive.
Okay, sir. Thank you.
Sir, can we store the address of a variable inside another integer variable
It
and
is
print that?
possible. We will come to that in some time, not in today's lecture. It's
Okay.
possible.
So if that variable is integer, will it print the address in decimal form rather than hexadecimal?
I'll answer these questions later. So hold on to your questions, but all your questions will be answered in due course of time. But all I want you to understand is the idea of variable, the memory allocated to a variable, the address of the variable, and how printf works. All these things, are they clear to you? I know that you have some more interesting questions. They are valid, but at least the ideas that I discussed in the session today so far, are you all with me? Anyone who have very problems with very fundamentals in the sense, so this much you should know how to use the printf statement. All right.
Sir, one question.
Yes.
You said like you said that in the memory location when it reads star d, it looks at the value to be written and then it replaces
Sorry,
the percentage d with
can you
that,
repeat
right?
again, Chinmay?
When we enter percentage d, the placeholder,
Yeah.
in a string,
Okay.
the system just reads the whole string, and then when it reaches percentage d, it looks at the value which it
Yeah,
has to print, and then it replaces percentage d with that.
that's true.
So all the values are taken in binary. So does that mean the memory will increase a little because we're replacing a percentage with 1, d with 0, and then there'll be more memory characters there?
No, I didn't get your questions. My speaker is also on low volume. I don't know how to increase it. Uh, So you are saying what is, so let's keep it simple. When %d is encountered, let's not worry about the performance. Whatever the value that is there, no, that I, it will be, that value will be printed in the position of %d.
Okay.
So nothing to do with anything else with memory in all those things. I'm not sure.
So I have a doubt.
Yeah.
So if in a scanf function, if we ask a question, and in a scanf function, if instead of ampersand I, we just put I, then it will be assigned a value, right?
No, no, it will not be assigned a value.
Okay, so the ampersand is required so that the in the place of the integer, the whatever the answer we give back, that is stored. So in the last cube or volume, those questions when we used scanf and put in the value of length. So what did it do
We
precisely?
will come to scanf again. So the important thing is for scanf, it needs to go and update the corresponding memory location. For that, it needs to know the address. By knowing the value that is present in a memory location, you cannot go and update that location.
Okay, sir. Okay. Thank you, sir.
So Chinmay, I think I didn't get your question completely, but I'll take up your question later. Okay. Yeah.
Okay, sir.
Sir, do registers have an address?
No, registers doesn't have address. Let's get going. So you have all interesting questions. I say all your questions are important, and but we need to, you know, and they will be answered. You will get answers. I am not trying to, no, say that the questions are not important. They are all valid questions, but the answer for all those questions you will get in due course of time. As the course progresses, you will understand many things in detail. So here is yet another program. So it has 4 variables, 2 integer variables I and j, 2 floating point variables x and y, and they are all initialized in this particular way. And you can see on line 10, we used this qualifier f at the end of the constant 43.2892 to explicitly say it's a floating point constant. And the same is the case on line 11. Even if you don't have f also, the program will still work though. And then we are printing the values of this ij, xy on the screen. The important thing here is the specifier that we use to print floating point numbers is %f. This is %f is the specifier that we use to print floating point numbers. So let's try to print this program and see what happens. So you can see that the value of all the 4 variables I, j, x, and y, they are printed on the screen. And you can also see that after this dot, this decimal point, 6 digits are printed. This is the default length, I guess. So here we gave only 4 digits, and here we gave just only 1 digit. But when we have printed it on the screen, 6 digits after float decimal point are printed. So there is a question, why do we have to use f after this constant? I don't think there is any difference, but in the textbook they suggested it's better to use f, but I'm not sure exactly what difference it would make. So please try it out and see what happens.
Sir?
Yes.
In one of the problems, sir, we had to calculate the volume of a sphere, sir.
Okay.
If we, in the formula, if we use like just 4/3 in the formula for 4/3 pi r square, it is giving a little different value, sir. If we are using 4.0 f by 3.0 f, then it is giving an accurate value.
Yeah, that's true.
Why is that
so
happening?
that's what we discussed yesterday, no? In the lesson. I am not sure if you followed yesterday's discussion. When you just use 4/3, then what happens is the value that you get 4/3 is 1. Because 4 is an integer, 3 is an integer. So good question. So you want to compute the expression for 4/3 pi r cube. I think so. So let's say, so the way you write this expression is if you just write 4 by 3 and pi value is 3.12 and you say r star r, then what happens is this 4 by 3 will be evaluated to 1 and it becomes a problem. So because 4 is an integer and 3 is an integer, the way integer division works is if the value is something like 1 point whatever, then this will be, this decimal part will be truncated.
Yes.
Okay, you only get 1. So that becomes an issue. So in order to solve this problem, you have to use, instead of 4 by 3, you have to use 4.0 divided by 3.0 star 3.12 star r star r star. This is what
Yes.
we should be using.
I remember this yesterday, sir, but I thought it was only for when we are defining a variable. Now I understood, sir.
No. And also, let's say if you divide an integer with a float, even if you just say 4 by 3.0, it will still work. Because if one is an integer and other is a float, then this integer will be promoted, this expression will be promoted, the compiler will promote 4 to 4.0 and it does this computation.
Yes. Thank you, sir.
Great. So are you all with me on this example? Is it okay? Can I go ahead with the next example? So now let's go to the second example, that is printf2. In this particular case, actually before I look into these two, let me take this example tprintf.c. In this tprintf.c, so far we are using %d in a very simple fashion, but we can include more qualifiers to the format specification. So here we are printing on line number 12, we are printing I in 4 different ways. The first way is, the first format specifier is %d, where it's just print integer I. The second format specifier, %5d, what it does is it allocates, it wants to print I as a, it's allocates 5 characters to print I. And percent minus 5d means, let's say if the character, if I is 1000 and but we are allocating 5 spaces, 5 positions for I to print, then minus 5d means print it in the left justified format. And percent of 5.3 means at least use the width that you should use for printing I is 5 positions, and at least use 3 positions.
Sir, can you repeat for -5?
I will run the code, and when you see, you'll understand it.
Okay,
that
sir.
will be the best. And same is x is a floating point number, and this 10 indicates that allocate 10 positions for printing the variable x, and dot 3 means whatever the value that is present after the decimal point, print only 3 positions, up to 3 positions. And E means you print it in some exponential format, and G means either use FRE depending upon the value of the variable X. So let's compile this program and see what happens. So that is the best way to understand this program. So GCC tprintf.c. Yeah. So you can see this is this particular way of printing 40D. This is we just used the format specifier. We just used the format specifier %d to print this. And this one we have printed using the format specifier %5d. What it means is you use 5 positions to print the value. So here you can see there are 3 spaces, because 40 is can be printed just using 2 positions. The rest of the 3 positions, there is a position 1 here, there is a position 2 here, there is a position 3 here. They are printed spaces. And then if you see a third example here, the format that is being used is % minus 5d. So you print the same, but this is what is called as a left justification. That is, you kind of whatever that you want to print, start printing it from the left. And then, so yeah, and then this one says, so this is allocate 5 positions, but at least 3 digits should be printed. So in this particular case, 40 is takes only 2 positions, but the specification is %5.3D, and because of that, what happens is no, at least since 3 digits should be there, 0 is printed before 4. So someone is asking, can we see the code together? Let's try to do that. Maybe it's better. Let's go here. And I will do one thing now. So new terminal. So gcc printf.c. So now you can see on line 12, we can compare on line what is the format specification on line 12 and how the characters are getting printed here. You can see this. In the last case, what this dot 3 specifies, when we are printing an integer, whatever after that dot tells, what is the minimum number of digits that we should be using to
Sir,
print the integer. Yes.
sir,
Yeah.
sir, in case -5D is used and it prints from the backside, then it should print 04, na?
No, it's not printing from the backside. What it means is start printing from the left hand side. 5 positions is the space that is given to you. Start printing from the left hand side, not 04, not like reverse it and print it. Because this between this vertical bar and this vertical bar, there are 5 positions. When we use minus, then that means print from the left hand side.
Sir, what if we use -5.3? Then it will put 040 from the
Yeah,
left.
it will put 040. That's true.
So what if you exceed 5?
Then it will be automatically, it will be expanded. The width will be expanded if it exceeds 5.
Sir, what if we use percentile 5D for a 6-digit number?
That's what happens. So all the 6 digits will be printed. It would not be a problem.
Okay, sir.
It's not an
Sir,
issue.
can you please explain again what does the 0.3 do?
The 0.3 is, it tells what is the minimum digits that we should be printing while printing an integer. Like for example, if you just print 40, you only require 2 digits, right? Yes or no? But if you use
Yes, sir.
3, if you use 3, then we want to print at least 3 digits, but there are only 2 digits. So the extra digit, you fill it with a 0.
So then in the second example, when you write only -10G, so -10 only, why doesn't it show 2, 1 and 0? Why does it show only 2, 1?
Now we will come to that thing later. So right now, are you all with me on the integer format specifiers for integer printing?
Sir, what is the G for?
Sorry?
Sir, in
For
percentage
integers,
point.
let's look at the integers first, and then we will look at the floating point numbers later.
Okay, sir.
Yeah. So if you are all with me on the integers part, like for example, if you want to try out and see, let's say if you use 10D, then what happens? GCC. You can see now 10 positions are provided to this from here to here. So let's get back here. There's a question on what if we use minus here. Let's see what happens. Now you can see 040 is printed from the left and 3 digits are used to print it. So when we come to floating point, this 10 specifies the width again, the whole width. So from here to here, it is 10 positions.
Sir, I have a doubt.
1 minute, let me finish and then you can ask, okay? And then So that dot, the 3 here specifies the number of digits that we should be printing. It's called as a precision field. It tells the number of the digits that we should be printing after the decimal point. The E format specifier, it helps us in printing the floating point numbers in this particular form. It is 8.392 into 10 power 2. That's what it means is. So what this means is, if you see, this is 8.392 into 10 power 2. And A3, this one, A39 point G, if I am right, depending upon the value of X, sometimes if the value of X is really big, then you will not be able to print it in a particular form, in which case you may want to use the exponential form of representing that floating point number. Because if you consider floating point numbers, the length of a floating point number, it could be, floating point numbers could take really large values. And so if it is a really large value, like then maybe this is printing it this particular way using 10 fixed whatever it is, it's not good. So by so this is by using this G option, the printf statement automatically determines whether it is nice to print the value in this form, or it is better to print the value in this form. And it makes the decision, and it prints accordingly. So now I am ready for questions. If you have any questions, I will take now.
Sir, am I audible?
Yes, yes, yeah.
Sir, in the first integer example, you said that the number after the point denotes the number of digits. So we had a 040 for
Yeah.
3.
Yeah.
But if we have 0.1d, which is smaller than the number of spaces for the integer, what happens then?
It is minimum, so it doesn't matter. Like the number is 5 digits, and then it doesn't matter. 3 is not like an upper bound, it's a lower bound.
Thank you, sir.
All right. Are you all with me on this one? Representing floating point numbers and...
Sir, I have a doubt, sir.
Not representing, printing floating point numbers and integers. Yes, please go ahead.
Yes, sir. In the second line where we are using float, sir,
Yeah.
for 10.3e, in the result that we have got, it showed 8.392e plus 02. Why do you have did we specify anything to make sure it is two digits, sir, 0 and 2? Why not just e plus 2?
I'm not sure. It is when you represent it in the exponential form with 3 digits precision after that dot, that one has to, it cannot use 8.3921. And so I'm not sure. You have to try it out and see. Anything that we do with floating points, we have to read the manuals carefully and see what is happening. You have a good observation, but I don't have an exact answer to your question.
Okay, sir. Thank
So
you.
it does some approximation to give that particular form of printing, but we have to dig in the details carefully when we are using it. E means print it in the exponential form. That is 8.392 E02. There is one more question on this. So what it means is print the variable in this exponential form. This is nothing but 8.392 into 10 power 02. This is the exponential.
Yes, sir.
Excuse me, sir.
Yes.
So, what does the G do, sir? Is the G truncating it to 2 points after decimal,
No,
or
no,
is
G is not truncating. So depending upon the value, it tries to print the floating point number either in this particular form on the screen, that is using F or using E. One of these two things it will try to use and print.
sir? But it's not matching with either of the two. I don't.
Well, it is, I think, so here we used minus 10. If you use maybe minus 10.3, it will match the first one because we used just minus 10G.
Sir,
See, yeah, so just 1 minute, guys, hold on. So I don't want you to get lost in these details. Okay, most of the time you don't need this level of control. Uh, so you can just get away with, like some, like just use my percent 10.3 or something like this. Most of the time you can use and get away with it. If you, these are all kind of language details. Like for example, if you are learning English language, there could be so many nuances in where to use a preposition and all that. When it comes to that, you will learn. So don't try to understand everything in a single shot. So I'm just introducing these ideas to you. So down the lane, if you require it for a specific programming purposes, you know that there is something like this, and you go look at the textbook or you go look at the manual, you go search Google and try to find the one that suits you. So my suggestion for all of you is, if you understand basic, no, like let's go back here, printf. If you understand this, okay, you are good. If you understand this, you are good. And then maybe you may also want to use something like this percent 10.2. That means print the floating point number and then 2 digits after the decimal. This level of basic understanding is good enough for you to in the most programming tasks. And in case if you need to use more involved ideas, you can understand those details while solving that particular problem. So yes, if you keep digging, it's a never-ending thing, and no one actually knows, because you have to go look at the manual or you have to go look at the textbook to understand the intricacies of what happens if I use some weird format specifier. You just really have to go look at the book and understand. Okay, some books will contain the details, some books wouldn't contain. So you have to go to the manual and see what the manual says, etc. All right. Yeah, the textbook has these ideas covered, and you read the textbook, try out different things and get an understanding. Just to conclude the discussion on printf, so if you see this particular code, you can see that on line 10 there are 2% Ds and but only one I to be printed, and on line 11 there are 2 I's and only 1% D to be printed. So I want you to again go look at the textbook and see. You can just try this program out and see what happens. Printf. So first of all, the compiler gives a warning. You know what? So here you are using two format specifiers, but there is only one parameter here. So the compiler gives warning in both these cases, but it doesn't prevent the generation of the executable. It just gives the warning. And if you see the output here, you can see the first output is 10 and the second output, it is some random garbage value that is being printed. And in the second case, for the value of I, the first I is printed and the second parameter that is being passed is ignored. So just be aware of these things, that when you make mistakes like this, you will get a warning, but the compiler will not stop your program from compiling your program into an executable. Let's look at one more thing. So int I float x. So here is a case where we are using %f to print I and we are using %d to print x. This is another case. So let's compile this program. This is printf3.c. Yeah, again you will see a warning from the compiler that you are using %f for I and you are using %d for x, because x is a floating point number, but %d is a integer format specifier. But it doesn't prevent the program from compilation. And if you print I, you are getting a 0. And if you print X, no, you are getting some random garbage value. So I want you to be aware of these things, that when you use these format specifiers and variables in an incorrect combination, the compiler will give you warning, but it doesn't prevent the compilation process to succeed. And when you run the program, you may get some garbage values. So be aware of these things. Be aware of these things.
Sir,
Yes.
sir, I tried like a percentage 10.8f and tried to print 839.21. So at the end of the decimal places, there are some garbage like decimal places. Like since it was ending with 839.21, it should go on with like 860 or
So
something.
Rudransh, can you hold on? So let me conclude this lecture. I will take your question.
Okay, okay.
So yeah, so this is the summary about the printf statement. In the next lecture on Friday, we will take the discussion on scanf statement. But most important thing I want you to understand is there are some principles are there. I want you to understand the principles, and there are details, and details are like very nuanced details. We have to carefully look at the book and try to understand what, when you do something, how the output will look like, things like that. Uh, so that's what it is. In the next class, we will study scanf statement. Uh, but one thing though, I will release the part 2 of lab 2, which is today. That is the problems from chapter 3. Back there are 8 problems. Those problems where only printf statements are involved, you can start working on them. All right. And the other thing is the survey. There are 2 surveys that I sent. Those 2 surveys are mandatory, because I really want to understand where you know how comfortable you are in the class and how we can help you. So those 2 surveys are mandatory. Please uh, fill them, fill those surveys by evening. Today evening there will be TA awards for 2 TAs. Those details will be posted. So please, those of you who have problem in the problems released in the programming problems released in the yesterday's lab session, you should take their help and start and solve those problems. All right. So now, so the class is over, and if you have any questions, you can ask. So there is one question that is being asked by Rudransh. Sorry, Rudransh, for cutting you. So now I can take your question.
Hello.
Yes.
So, sir, I was trying like percentage 10.8f. Right?
Percentage 10.8. Let's see. Okay.
So I was trying percentage 10.8f, and at the end of like the number is 839.21, but the
Okay.
number is printed out to be 839.21 then 2197, something like that. There are some extra like decimal places which should have been 0, but there are some.
Ha, 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 ha. Good question. So let's try this. Very good question. Yeah, let's compile this. This is what you tried, right?
Yes, sir.
No. What this is printf dot.
Sir, it's tprintf.
Is there any tprintf only? Okay, sorry. So awesome. See, what happens is some floating, you don't have an exact representation of floating point variables in the computer. So even though when you use 839.21, 839.21 may not be exactly representable in the computer. So the closest, it will be approximated to the closest value. So that's what you are seeing here. The internal representation of 839.21 is this 839.21002197, so on and so forth.
So, but why can't I just put zeros there? Like,
no, but there is a reason for it. The reason for it is in the floating point representation, what happens is all numbers cannot be exactly representable. So when 839.21 is stored in variable x, it is not stored as 839.21. It is stored as a floating point number which is nearest to 839.21. A floating point number which is representable and closest to 839.21.
okay, yeah, sir, I had another doubt, sir. I tried, like usually the limit, like you said, is default 6 decimal places, right? So I tried giving a float variable that had 6 zeros and then 9.
Okay.
And then when I tried printing in an exponential format with minimum 3 decimal places, that format specifier, it just rounded it off to 1 e power minus 0.6.
Okay.
So why did that happen? Can't it print it properly, like say 0.9 into e power minus 0.6? Can't I do that?
If I see the code, I may get some idea, but
So all I did was I just assigned the float variable as 0 point with 6 zeros and then 99 something.
0 point?
0 point and then 6 zeros.
Ah.
And then 9.
Okay.
And a few random numbers after that.
Okay.
And then I in the printf statement, I gave a left justified format specifier with minimum 3 decimals.
So let's try it out. So let's see what happens. Okay, hash include. So just want to tell other students, so the class is done. We are just hanging around and trying out few things. So no problem. So if you want to leave the class, it's fine. So what is x equal to
0.6 zeros.
Okay.
And then 9 and then some random numbers. Yeah, that's it. And that's all. And now we're supposed to print x, the value of x with minimum 2 or 3 decimal places. Yeah,
Okay.
something like that. And then print x. But for me, it rounded it off to 1 into 1 e minus 0.6.
So you just wrote %10.3 without a format.
Oh yeah. Sir, percent, sir, no.
Oh yeah.
You need to give formats. Yeah.
Let me see. Let me use 10. Yeah, so this is looking all right, no?
I don't know. For me, it rounded it off to 1. Oh, I didn't use F, sir. I used E.
Oh, you used E, huh?
I used E, and I didn't put 10 spaces. I put a few only, like 2 or something.
Let's see. You will try to print it in two forms.
Again, X.
Yeah.
Oh, yeah. Okay, but here it's for me. It gave 1 E minus 0.6. I'm not sure why.
Okay. And let's see, since you're all here, let's see what happens if I use percent 10.3G.
I'll probably try again then.
Okay, so see G in this particular case, it thinks it is better to print it in the exponential form. So it is printing that. So are you able to see the difference? Because in the earlier example, G printed without not in the exponential form, in the regular form. But here G is printing this particular format specifier. It is making the value print in a exponential form.
Sir, here in G, even though we specified 0.3, it is showing only 2 decimals.
Sorry?
Here we use 10.3 G now, sir.
I didn't get you.
We use 10.3 G here now, sir.
Yeah, that's true.
But still it is showing only 2 decimals after.
I think, see, what that 0.3 for G, we have to see. It means if it says some, I don't know what exactly G does, so we have to read.
Checks the power, so if it's more than 10 power 3, then it will represent as E or otherwise just float.
Oh, is it? Okay. Uh-huh. If
But,
it's more than 10 power 3, it represents it as an E, yeah?
Yes, sir.
Okay, excellent, Kishore. Thank you.
So will it ignore that point, whatever is after points?
I'm not sure why it is not printing 9.123 into, because we use 10.3, right? So
yes, sir.
Why it is ignoring 3, I don't know.
Okay, sir.
All right, so that's all for today. So are there any more questions?
Sir?
Anyone having trouble with your homeworks also, you can ask me. I will hang around for some time.
Sir, I have a doubt. I tried out the using printf on the right side of the equal to sign as an R value, I suppose. It gave me a different sort of output from yours. May I show you?
So what is it you tried to do, printf?
Yeah, to print the length of the output.
Okay, and
In yours, when you tried it, it didn't print the output. It just gave you the length of the output, right?
no,
On
it
my
printed, no?
oh, did it?
It
Okay.
printed the output and also returned the value, right?
All right, all right. Thank you.
Yeah, of course.
Okay, no, so it's working for me now. So I'm not sure what happened, but yeah, it seems to be working now.
Good. I will end the
So,
recording here.